So Module 4, Part 1, this is about torsion. So torsion refers to the twisting of a structural or a machine element when subjected to a torque or the twisting moment. So we can see sa figure natin, we have a solid circular shaft. It is fixed at point A, dito. So fixed siya dito. And then it is free at point B. So recalling about fixed supports, they can carry or they can resist mga vertical, horizontal, and moment loads. Since our system is acted upon by a torque, this T, clockwise rotation or direction siya, we expect it to twist about the x-axis as shown. So dito siya nagtitwist sa x-axis and it is clockwise. So this results in stress and strain. So partner siya, di ba? So the stress daw, it happens over the cross section. So this is our cross section. Ito yung solid shaft natin and ito yung cross section niya. So all part naman niya may cross section siya na ganyan and even at A. So these are the cross section. Dito nangyayari yung stress niya. And then the strain is an angular displacement and it is happening along the length of the material. So strain, it happens, strain is the displacement, diba? So ito yung displacement. From this original line, so we have an original flat line. So dahil siya sa twisting natin, nagkakaroon ng displacements. Ito yung mga displacements na to. So it happens along the length ng ating material. So we are concerned, of course, sa mga problems natin, yung stress and strain. So to solve problems like this, we have syempre yung mga assumptions natin. So we can convert ang isang engineering situation in something mathematical para ma-solve natin siya. So number 1 assumption, cross sections remain plane and perpendicular to the axis of the shaft. So for our figure, since yung rotation ng torque natin is about the x-axis, so yung plane down natin, for example, kunin natin yung plane sa point B, ang plane na to will remain plane and it is always perpendicular dito sa axis of rotation ng torque natin, which is the x-axis. So ito daw, kahit meron o walang torque, ang plane na to will always be perpendicular sa x-axis or yung rotation axis ng torque natin. Number 2 assumption, cross sections do not deform. So since this is our cross section, we consider again yung cross section sa point B. Etong cross section na to will not deform. So kung circle siya, it will remain a circle. Flat, it will remain flat. Number 3, the distances between the cross sections do not change. So itong ano yung distance between cross sections, let's consider yung cross section sa point A and yung cross section sa point B. Ang distance between them is yung length na L. So meron o walang torque, magi-stay na length L ang distance between sa dalawang cross sections na to. So let's consider section dito. So this section to the section sa point A, ang distance ay x. So, meron o walang torque, it will remain x. So, with these 3 assumptions, let's analyze the system. So, to analyze the system, let's isolate an infinitesimal segment ng shaft. So, let's pick a differential element at an x distance from point A. So, since infinitesimal differential element, let's call its differential length as dx. So, eto tayo ngayon. Ito yung element natin. So, maliit na segment lang to ng shaft and then we further make it smaller dahil lang kukunin lang natin sa kanya kung ito yung segment natin, ito yung buong circle niya or radius niya, kukunin lang natin ay isang small part sa loob niya. So, we peel yung outer part off. So, aalisin natin ito. magtitira lang tayo ng isang maliit na portion. Let's call the radius of that small portion as rho. Nasaan ba yung buong radius ng segment? Nandito. Ito yung R, di ba? Ito, yung from the center point ng circular shaft to its surface. Yun yung buong radius. Pero hindi natin yung kailangan. Yung small portion lang with a radius rho lang ang kailangan natin. So, that's our first parameter. So, next, a-applyan na siya ng load, which is a torque, a twisting moment. So, saan siya nagtitwist again? It's about the x-axis. So, ibig sabihin, kapag tinwist mo ng clockwise ang direction, if you have a line segment here, let's call it CD, kapag nalagyan ng torque ito, magtitwist siya, syempre, you expect our material to twist. So, magkakaroon tayo ng point D prime. Okay, so meron na tayong point D prime dahil nag-twist nga. So, fixed ang ating center point. Hindi siya gagalaw. Ang nagtitwist-twist lang yung palibot ng shaft natin. And then another, nag-stay ang point C kasi nga fixed tayo sa A. So, meron tayong twisting na nangyayari dahil doon naka-fix to, naka-fix si C, naka-fix ang center point ng cross-section, si D lang ang gumalaw. So, meron tayong twisting na nangyayari. At what type of stress is that? Kung observe nyo, yung isang portion ng element, makikita mong nangyayari sa kanya or stress na na-experience niya is shear stress. And then, meron siyang shear strain na nangyayari din. So, sabi nga natin sa definition kanina, the stress sa mga torsional elements happens sa cross-section nila. Nandito ang stress. And then, ang strain ay nangyayari sa along the length ng material. Nandito yung strain. Since shear stress ang nangyayari, so let's call this tau. And then, ang strain nangyayari is a shear strain. Kaya gamma ang symbol natin sa kanya. Okay? So, ano pang parameter ang nakikita natin? Yung displacement na nakikita natin. Dahil sa displacement ng point D from point D to D prime, meron kang angular displacement. So, this angular displacement, let's call it d theta since infinitesimal or differential segment lang ang kinoconsider natin. And this naman, sa side na to, ang displacement, yung angle natin is yung shear strain natin na gamma. So, next, we need to evaluate na or get some equation out of this system na. So, ano yung nakikita nating common point dito sa dalawang displacement natin? So, makikita natin na ang common point nila is yung line na D prime. Equal siya kung dito mo siya titingnan or dito mo man siya titingnan. Dahil isang line lang yan. So, using, again, yung sector of a circle, yung sectorial length, which is itong ginamit natin to. Sectorial length is equal to yung theta times yung radius. So, if gagamitin natin ito sa case natin dito, our length is the D prime. And then, evaluate muna natin siya dito sa cross-sectional side. So, ano ang magiging theta niya? Of course, it's d theta. And then, ano ang kanyang radius? It is rho. So, that is equation 1. And then, next, evaluate natin ang d prime dito sa side ng length naman. So, our d prime dito ay, ano ang angle natin? It is gamma. And then, ang length is si dx. So, these two, we can equate to each other kasi nga, same silang equal to d prime. So, d theta times rho So, equal sila kay gamma times dx. So, since we are concerned sa stress and strain, let us isolate strain. So, strain is equal to rho times d theta over dx. So, meron tayong strain, no? So, we have an equation, yung lumang equation natin ng stress and strain. So, we can equate. Let's recall this equation. So, let's call it equation 3. Pwede natin substitute ang equation 4 na to into equation 3. So, 4 in 3. So, our shear stress, tau, is equal to modulus of rigidity times yung equation 4, which is rho times d theta over dx. Times to, hindi minus. So, this is our equation for shear stress. Pero, it is in terms of differential, different d theta and dx pa lang. So, we need to further simplify it, itong equation na to. So, let's go sa let's show muna yung distribution ng shear stress. So, eto si shear stress, it is dependent kay, as you can see, dependent siya kay rho. It is directly proportional kay rho. And then rho, kung mag-start ka sa center point ng cross-section, habang lumalayo siya sa center point, lumalaki ang rho natin. So, ibig sabihin, habang lumalayo ka sa center point, lumalaki din si shear stress kasi nga directly proportional sila. And ano ang largest possible ng rho? Of course, it is the radius. So, it means maximum shear stress happens dun sa surface ng ng circular shaft natin. And makikita nyo, relationship is triangular. Kasi from center point, 0 ang rho, so 0 ang shear stress. Pero habang palayo ka ng palayo sa center point, lumalaki ang rho mo, pataas ng pataas hanggang ang shear stress, pataas ng pataas hanggang ma-reach niya ang R, total radius ng circular shaft, that is your maximum shear stress na. So, nakakuha na tayo ng isang equation, no? This one. So, let's further evaluate yung system para makakuha pa tayo ng iba pang equations. So, ano pa ang pwedeng gawin? Of course, equilibrium equations. Or yung i-undergo natin ng system sa state of equilibrium. Kasi nga, yun naman ang ating goal, to make the system equilibrium. Kasi kapag nandito na sila sa equilibrium, ibig sabihin, nare-resist natin yung mga applied loads. So, in equilibrium, it is the applied loads versus yung strength ng material mo. So, what is our applied load? Is this the torque? So, versus nyan yung material mo. So, ano ba yung mga properties ng material mo? So, let's look at this figure. So, ito ang buong area. Isang buong area ng circular shaft to. Let's take a look at small area. An infinitesimal differential area ulit. Isang portion ng section natin. So, let's call this, of course, dA, differential area. Itong area na to, may capacity siya to oppose yung torque natin. At ano ang nangyayari sa cross-section? Diba? Dito nangyayari ang shear stress. So, itong area na to, meron siyang corresponding force na kayang i-apply or ibigay to negate our torque, applied load. Of course, differential force yon. Since differential area, may kaya siyang ibigay na differential force to negate our torque. And from the equation natin ng stress, which is stress equal to force over an area wherein our force is dP and then our area is differential area. So this is our shear stress. Ano pa ang makukuha nating equation? Diba? Torque or moment, recall, is equal to force times distance. Moment can be a twisting moment or torque or a bending or flexural moment. So for this one, it is a twisting or twisting moment. So torque tayo. So ano ang we can get yung corresponding moment na kayang ibigay naman ng differential force natin. So our moment here is yung torque. This is the torque ng material na kayang ibigay ng material na. So torque is equal to ano yung force natin? It is differential P. And then ano yung perpendicular distance or moment arm niya? It is rho. So times rho. So let's call this equation 2. So nakakuha tayo ng dalawang equations. Then recall or kunin mo yung equation natin kanina, yung nagawa natin, yung shear stress equation na nabuo natin. And let's apply dito sa lagay na natin siyang equation 3. Ano pwede natin gawin? So, pwede natin equate si equation 1 and equation 3. Equate equation 1 and 3. So, magiging dP over dA is equal to G times rho times d theta over dx. Then, let's isolate P. Isolating P, ibig sabihin, either it's like cross multiplication or multiplying both sides by dA. So, para ma-isolate si dP. So, magiging ganito na siya times dA. So, this is our new equation. Let's call it, ano na tayo, equation 4. So, next, getting yung equation 2 naman. Gamitin natin si equation 2. Doon natin gamitin si equation 4. Let's substitute equation 4 in equation 2. So, equation 4 in equation 2. So, equation 2, magiging na siyang substitute na natin yung equation ni dP. That is rho dx times dA. So, si dP pa lang yun and then 0. Huwag mong kakalimutan 0. So, this is now yung torque. Equation natin kay torque. So, makikita mo 2 times na nag-exist 0. Let's put them together. G times rho squared na siya. Then, meron kang d theta over dx and dA. So, we have now a new equation of torque. So, this torque is the capacity or yung strength ng material to resist yung applied torque. Kasi, diba, ito naman yung kinukuha natin, yung strength ng material, resistance niya sa torque. So, hindi yan yung torque na load. So, this is the torque resistance ng material natin. So, they are in terms of differentials pa. So, if we integrate that, if we sum up lahat ng mga capacity ng differentials, it will be equal sa total torque na kaya niyang ibigay. So, let's integrate. So, labas natin si D, G and dA, este si d theta over dx times so, purposely nilabas ito Kasi if you recall sa statics, meron tayong na-derive na ganyang equation, and that is equal to polar moment of inertia, J, na equal to the integral ng radius times your dA. So that is polar moment of inertia ng cross-section mo. So let's rewrite that in terms of J na natin siya. So, we've simplified yung equation. So, simplify pa natin siya further. Let's cross multiply. So, it will be G times J d theta. Ihuli ko lang si d theta. And then T times dx. So, isolate natin si d theta. Because this d theta, meron siyang significance. This is your angle of twist. So, integrate ulit. Kasi hindi siya integrate kanina. So, this will be theta na. And then, this is T, G, J. Because those are constants. And then, i-integrate mo na lang is dx. From 0 to length. So, pag integrate mo yan, from 0 to length, L, this is equal to length. So, this is your formula for the angle of twist. So, kung babalikan natin yung figure, ano nga ba yung d theta natin? Yung twist nung cross-section natin, di ba? Nasaan na yan? Ito. This is our word d theta. So, that is an important parameter dahil it tells you gaano kalaki yung twisting ng material mo dahil sa torque na applied torque. This one, yung buong length niya. Dahil in-integrate na natin siya, diba? Kasi yung ina-observe natin dito pa lang itong dx lang na to So, we integrate that from 0 to length, total length na L, makukuha natin yung total angle of twist, which is theta. So, importante to kasi it will tell you kung gaano siya kalaki yung inikot niya. So, that is angle of twist. So, importante yan. You memorize this one. So, isa pa lang ang buong equation na nakukuha natin, no? This corresponds na rin dun sa displacement niyan. This one. Angle of twist is the displacement. If you want to get yung shear strain, meron tayong equation na nagawa kanina. Pero undone pa siya dahil nga naka-differentials pa lang sila. So, next natin, kunin muna natin si tau. So, since undone pa to, let's finish it using yung angle of twist. Equation na angle of twist. Since si angle of twist, nabuo na natin siya, let's complete si shear stress. So, anong pwede natin gamitin na equation dito para ma-complete natin si shear stress naman? Para makuha natin ang complete equation ng shear stress. So, ano ang pwede natin gamitin equation para ma-simplify natin ang equation ni shear stress? So, this one and this one may similar silang mga parameters. Ito and ito, maka-cancel out natin sila. Isolate natin si G times d theta over dx. So, magiging d over j na lang. And then, ipagpalit natin siya dito. Rewrite natin itong si tau para magkasama yung mga dapat nating i-cancel or palitan. So, ipalit na natin ito. This equation, ilagay natin dito. So, magiging tau is equal to rho times T over J. So, makukuha mo yung shear stress at any radius from the center point. Pero kung gusto mong kunin ang maximum na stress, that happens sa surface ng shaft, diba? So, gawin mo siyang ganito lang. So, if you want to get strain nga, yung kanina, si strain na, shear strain na yan, anong pwede mong gamitin?